Suppose we just welcome the baby into our world and we are super excited. How time flies. We were babies yesterday. Today we are grown up and we have a baby. And our baby will grow up one day to be like mom and dad. And in our excitement, we decided to chart the baby's growth on every of his birthday. We make him stand up against the vertical wall and mark his height on the wall. This curve, this line encodes details of our baby's growth. There are several questions we can ask of this line. One of the most important ones is, how fast is our baby growing? In other words, at what rate is our baby's height changing per age or per year? From the graph, we can see that from the 0th birthday, that is from birth, to the first birthday, the height increased from 10 metric units to 5 units to 15 units. That is an increment of 15 minus 10 for an increment in age of 2 minus of 1 minus 0. That's from the 0th birthday to the first birthday. That will give you 5 all over 1, which is 5. Then from the first birthday to the second, we see that the height changed per age from 15 units to 20 units. That's an increment of 20 minus 15 all over 2 years minus 1 year, which is 5 all over 1, which gives us 5 again. Then from the second birthday to the third, we see that the height increased from 20 to 25 units. Hence, the change in height per change in age is 25 minus 20 all over 3 years minus 2 years. That gives us 5 over 1, which is 5. That means our baby's height increased by constant increment of 5 units of height per age, as we can see from the graph. However, human height and human growth and growth in general do not follow a straight line. They follow rather a curve. In other words, they are not linear. For example, suppose you own an eel, and in the first year it gives birth to another eel. You now own 2 eels. If in the second year they both give birth to an eel each, you will own 4 eels. If this trend should continue, then in subsequent years you will have 8, 16, 32, 64 eels, and so on. Now we can represent the number of eels at each year with a graph. In the starting year we had 1 eel, that's halfway to 2. In the first year we had 2 eels. In the second year we had 4 eels. And in the third year we have 8 eels, and so on. Now we can join all these points with a curve. And like in our first example, this curve encodes details of our number of eels every year. Likewise, there are several questions we can ask of this curve. And one of the most important ones again is, how fast is our number of eels growing? Now we say that from the starting year to the first year, the change in population of eel per year was from 1 to 2, that is 2 minus 1. From the 0th year to the first year, which is 1 minus 0, that gives us 1 all over 1, which is 1. Then from the first year to the second year, the number grew from 2 to 4. That means the change in population with respect to the change in year was 4 minus 2 all over 2 years minus 1 year. That will give you 2 all over 1, which is 2. Then from the second year to the third year, we saw that the number grew from 4 to 8. Means change in the population per year of 8 minus 4 all over 3 minus 2, which is 4 all over 1, which is equal to 4. We see here that the change in the population of eels is not constant. In other words, the slope of the graph, as we can see from the graph, is not constant. We cannot find a constant slope for the entire graph. We can only find the slope of the graph, that's the rate of increase along the curve, at each and every point. To do this, we have to draw a tangent to the curve at the point of interest. Now, a tangent is a line which passes through a curve, which touches a curve without cutting through it. Now, if we draw a tangent to the curve at any point, the gradient of the curve at that point is equal to the gradient of the tangent at the point, which is the vertical rise divided by the horizontal run. Now, however, if we, instead of drawing a tangent to every point on the curve, which is cumbersome, if we can represent this curve with an algebraic equation which gives us our population function, then we can use algebraic methods to find the rate of change along the curve. Now, for example, for a hypothetical child's growth curve, we see that at birth the height was 10 units, then on the first birthday the height was 15 units, which is 10 plus 5, and on the second birthday the height was 20 units, which is 10 plus 10, that gives us 10 plus 5 times 2, and on the third birthday the height was 25 units, which is 10 plus 15, which is 10 plus 5 times 3. Likewise, we can write the height on the first birthday as 10 plus 5 times 1, and the height at birth as 10 plus 5 times 0. Hence, generally, we can represent this what the height at every age. We can write the height at every age as 10 plus 5 times that age. Now, there is no sudden jump in height. The height increases gradually with age. The height increases gradually with age. We have age is equal to 10 plus 5 times the age. Now, for every increment, slight increment in age, the height also increases by a slight amount. Now, we are trying to find the rate of change of the height with respect to the age. So we are going to make this the subject of the formula. If you do not know how, please watch my video on change of subject of a formula. Then the increment in height is 10 plus, let's open this bracket, we have 5a plus this, then we bring h to this side minus h. Now we know originally that h is 10 plus 5a, so the increment in height is 10 plus 5a plus 5 times increment in age minus 10 plus 5a. So 10 plus 5a is going to cancel out of the equation, and we have increment in height is 5 times increment in age. So the increment in height with respect to the increment in age is 5, which we got for our hypothetical child's growth curve. So for the smaller the increment, as the increment goes very smaller, then this increment in height for a given increment in age will give us the gradient of the curve, which is 5 units. This is differential calculus.
If you like this video, please subscribe to my channel and turn on notifications for more videos like this. You may as well visit my website www.everydaymaths360.com for more lessons, learning materials, and prep packs comprising over 1,000 thoroughly explained solved practice problems. Thank you.